now go to the next speaker, that is Dominic D'Agostino. And he will give a lecture on utilizing nutritional ketosis to improve infantile onset pompe disease phenotype in mice. And he is an associate professor at the University of South Florida. I give you the floor.
Yeah. Thank you. It's great to be here. I want to thank the organizers for the invitation, and thank you all for being here. I've been really inspired by the science so far, and really inspired to see patients at a conference where everybody can learn and network together. Today I'll be talking about utilizing what we call nutritional ketosis. We've kind of reframed that terminology to ketone metabolic therapy because there's a vast variation between different ketogenic diets, and we also study exogenous ketone supplements. So the combination of those two is what we call ketone metabolic therapy. So we've been testing this in various model systems and developing them for warfighter performance and resilience applications. So it's great to be applying it to this disease model. We're looking at an infantile onset pompe disease model, Phenotype unique model system that I'll be describing. Here are my disclosures. I'd like to just highlight we've gotten research support in collaboration with Pompe Warrior Foundation and Spark Therapeutics, which has funded the research that I'll be showing you today, and a number of patents related to what I'll be talking about today to apply to some of the data. So I think in the interest of time, I'll just pass through the outline and really just describe ketone metabolic therapy. There has been emerging interest in the idea of substrate reduction for Pompe disease. And ketogenic metabolic therapy is much more than just substrate reduction, right? Because utilizing carbohydrate restriction reduces glycogen synthesis and glycogen stores, but also stimulates, by virtue of reduction of liver glycogen, the production of ketone bodies. And ketone bodies are neuroprotective, they're cardioprotective, anti-inflammatory, and they have anti-catabolic effects. We study ketone bodies in the context of cancer cachexia, for example. So ketones can also promote antioxidant protection, mitochondrial function and biogenesis, and there's also evidence of increased autophagic flux in the context of elevated ketone bodies. So there are many different methods in which you can induce and sustain therapeutic ketosis. There are many different types of ketogenic diets, including the very high-fat classical ketogenic diet, modified versions of the ketogenic diet. There are ketogenic fats in the form of medium-chain triglycerides that can be consumed that actually elevate ketone bodies independent of carbohydrate restriction. And also exogenous ketone supplementation. There are at least 60 different molecules. We work and develop many different types of ketone technologies and apply them to different model systems. Exogenous ketones can circumvent the dietary restriction typically associated with producing and sustaining therapeutic ketosis. So these can be used in the absence of a ketogenic diet. And that's what we do for more of the military applications. So an elevation of ketone bodies can supply energy to the heart, to the brain specifically, and also to muscles. And there are commercially available technologies, including wearable continuous ketone monitoring systems that can measure this metabolite and this signaling molecule in the blood. So ketone bodies are very powerful signaling molecules. I won't go into all the different mechanisms, but these are all the different mechanisms that we study, including epigenetic mechanisms, including beta-hydroxybutyrylation, where the ketones can directly interact with the histones and augment gene expression. Ketone supplementation has been used. In the last 10 years ago, there was no studies on clinicaltrials.gov registered. So there are 147 studies if you look at ketone supplements. And these can be ketone esters, things like 1,3-butanediol, which is not an exogenous ketone, but a precursor. Ketone salts and also MCT would fall under that category. Here are a couple examples that we're doing studies at Duke University on warfighter performance and resilience in their environmental chambers. And many different emerging applications of exogenous ketone therapy, including even type 1 diabetes, alcohol withdrawal syndrome, migraine. So that's sort of like the general idea behind ketone metabolic therapy. There's different ways to implement it and sustain it. So we're applying a ketone metabolic therapy to a pump, a fairly new, not very well characterized murine model of pomp. So this is a knock-in model, a CRISPR-generated knock-in model that has the cellular, the biochemical, the molecular, the physiological, and the histological similarities to the knockout model. So including an elevation of glycogen and including a decrease in the enzyme activities. And this particular model also presents with cardiomyopathy, hypertrophic cardiomyopathy. So we've used this model in our studies, and we bred them up, and we've been characterizing and applying the therapies to them. So the first objective is really what I'm going to focus on today, and that's to determine the effect of what we call ketone metabolic therapy, which can be ketone supplementation or the ketogenic diet with or without ketone supplementation. And we look at blood metabolites, glucose and ketones. At the end of life, we're going to look at lactate, which I think is important, body weight changes, motor function, hypertrophic cardiomyopathy with echo and EEG in this pomp model. And following the end of life procedures, we're at the 9-month period right now in our study. We're going to look at glycogen content, autophagy, mitochondrial function, and then epigenetic profiling too in this. And that comes later on. I don't have that data yet. But the models in which the methods that we employ include the therapy is a standard diet with the wild type model against the null mutation. This is a homozygous model that we're looking at. And we have a standard diet with ketone supplementation, a ketogenic diet by itself, and then the ketogenic diet with ketone supplementation. The supplement that we use in this study is racemic 1,3-butanediol. 1,3-butanediol, when we added it to the standard diet at a dose of 20%, was toxic, and we lost a couple mice. So there are, like I said, there are many different exogenous ketone supplements. 1,3-butanediol is probably one of the more weaker exogenous ketones, and also maybe one of the more toxic ones too, because alcohol dehydrogenase uses it to break it down. But with that said, this molecule is cheap. It's been around since the 1950s, and we've had a lot of experience with it. Although there are other exogenous ketones that can be more efficacious. So just keep that in mind as we present the data. So we have our standard diet is the NIH 31, I believe. And we use a very different ketogenic diet that has evolved in our lab, in particular for some rodent studies with Alzheimer's and cancer. It's much, much higher in protein, about 2 to 3 times higher. So it's 23% protein. And the fats that we've incorporated into this diet are a large percentage of medium chain triglyceride, which are ketogenic fats. So we get an elevation of ketone bodies that are similar to a much higher fat version of the ketogenic diet. So we want to avoid fatty liver, which we did. So after 9 months of this modified, in some cases supplemented ketogenic diet, we saw no signs of hepatic steatosis after 9 months of feeding this particular ketogenic diet. And the circle here is where we're at in our study right now. So we have not completed the end of life. But we've done a number of different measurements, including blood metabolites after 6 months. And I think it's important, in the interest of time, to draw your attention to the the pomp mice that were eating the ketogenic diet plus ketone supplementation, which is 1,3-butanediol. We look at glucose and ketone bodies, but the main biomarker that we're interested in, that is kind of used in various clinical trials now, is the glucose ketone index, which is simply the measurement of glucose over ketones in millimolar concentration. And the combination of a ketogenic diet and ketone supplementation produces a pretty profound lowering of the glucose ketone index. Lower is better. So lower is more therapeutic. So this glucose ketone index is sort of associated with therapeutic effects in the context of epilepsy, seizure disorders, and also cancer. So the body weight changes over time were pretty remarkable with the ketone therapy. There was a drop in body weight with the ketogenic metabolic therapy. I'd like to mention that the standard C57 black 6 NJ mice are kind of fat, right? So they are chunky mice. So we are seeing a decrease in, it's almost like a restoration of a normal body weight, because when the mice eat and they reach a certain time point, they tend to be a little bit overweight. So I'll just jump right into the data. Our motor function, specifically on the balance beam, I'd like to mention that we did not do the rotorod because we were concerned that these mice may be fragile, and if they fall off the rotorod device, we did not want to injure them. So we started with a balance beam, and we went from 1 inch to 3/4 to 1/2 inch to 1/4 centimeter over time, and we train them on that, and we score them as they reach the endpoint. So 4 would be the highest score once they reach this box here, if they can make it across. And just like to mention that the Pompe mice eating the ketogenic diet and butanediol really achieved a non-significant, really restored the motor function in the context of the balance beam. So we saw what appears to be a therapeutic effect on that, and there was a really nice effect on muscle strength using ketone metabolic therapy. The biggest effect was with the ketogenic diet that was supplemented with ketone supplementation, 1,3-butanediol. We saw significant strength gains at the 9-month point. So actually we saw gains in strength. We looked at holding impulse, also called the hang impulse, which we do 2-time trials with 20 minutes rest in between. And that's simply the body weight in grams times the time that they spent on there. And the treatment group actually outperformed the wild type. So significant increase in muscle strength with ketogenic diet with ketone supplementation, and that really surprised us. We're right at the end point of the study here, and my medical student, Natalia, just sent me pictures as I'm on the flight here. So there does not seem to be, we are just dissecting the animals now. This is a female animal with the standard diet leg muscle. You can kind of see this is the typical kind of wild type, and a female diet eating the ketogenic diet and butanediol leg muscle. There does not appear to be any overt pathology in the muscle, but we have to do the analysis. And we are just starting to do the echocardiogram using the Vivo 3100, heart rate, EKG, echo. We're doing a wide variety of things. We have not analyzed the treatment group yet because this is the very last procedure we're doing at the 9-month point. But this particular model does have hypertrophic cardiomyopathy. The heart rate is different. And also the left ventricular posterior wall is significantly thicker in these mice. So this is just not the treatment group. We have not analyzed the treatment group yet, but we are doing those studies. So in summary, the Pompe mice treated with ketone metabolic therapy, specifically in the context of a ketogenic diet that's supplemented with ketone supplementation, this can achieve ketosis. And 1,3-butanediol, we did find that it is toxic to the Pompe mice at 20%. So we had to back down to 10%, incorporate that by weight into the diet. The ketogenic diet with butanediol had the most therapeutic glucose ketone index, resulted in the best improvements in motor function and strength. We still need to do AIM-2 after the end of life. Future directions include really optimizing the ketogenic diet. There's a lot of room for innovation in engineering the diet to be optimal for Pompe, I believe. And also there's, like I said, 1,3-butanediol is probably the least best exogenous ketone that we can use for this. There's monoesters, diesters, triesters, and there's different forms of exogenous ketone salts that can be used. We think that you can get a significantly more potent and more highly tolerable exogenous ketone and improved safety profile too. So we have yet to study that. Of course, we want to combine ketone metabolic therapy with ERT and potentially autophagic agents and things that can enhance and improve muscle strength. And with that, I'd like to thank you for your attention, and really like to thank my medical student, Natalia Thomas, for conducting much of these studies. And it's been a team effort. I'm just up here talking about it with you, but they are in the trenches doing the work. And just like to highlight, my wife has been incredibly supportive. She's also a neuroscientist. And here are my cows. We have a bull, but I don't ride it. But we live on a farm. And yeah, glad to answer any questions you have. Feel free to reach out to me if you're interested in this research. Thank you.
Thank you very much, Dominique.